going to give you what I think is the key right here to trigonometry. The key to trigonometry is the word relative, and this is where everyone messes up, right? So I'm going to stand right here, and I'm going to say, who is opposite from me? And hopefully you would say that he's opposite from me, right? I'm still me. I'm still in the same place in the room, but now I'm here. Who is opposite from me? Audrey is opposite from me. That changes the answer completely, because the problem with trigonometry that we don't talk about is that we use relative terms. Opposite only means something if you know where the hell you're standing. Adjacent only means something to me if I know whether I want it adjacent this way or adjacent this way, because it gives me two different answers. So I'm going to show you some goofy tricks. Here he is. So excited to see him. Little baby Sokotoa. So when I first started teaching math 36 years ago, yes, did I think that Sokotoa sounded like a Native American word? Sure. Did I make it a Native American girl? Yes, I did. Did I cut out the Land of Lakes butter girl and put her on things? Yes, I did that as well. Was it racist as hell? Absolutely. And have I stopped doing it? Yes, I have. You know better, you do better. So now, Sokotoa is an alien. Is it racist to aliens? Maybe. But you know what? They're going to come here and land, and they can kill me if they want, right? So here's what. I am going to do a thing tonight that some of you, for Algebra 2 trig kids, are going to think that's a baby step. But there is a method to my madness. The deal is this. The key to trig is what's called visual orientation, meaning you have to know where you are visualizing from. And the act of writing stupid baby Sokotoa on your paper gives you that visual orientation. Do you have to do it? No, because some of you are going to be pros. You're not going to need to know it. But I do it every time because it is different whether I am to, oh, sorry, Sokotoa, I did not mean to write on you. If this dude, if he's standing up here, this is opposite. And if he's standing down here, this is opposite. So I need to always know where to stand it. That's the first thing. The second thing is because we're now in pre-calc and when we were in Algebra 2, we don't use X as much for angles. We use a symbol that looks like this. And for those of my seniors heading to the Greek system next year, that is the Greek letter theta. That is theta. So when you see that circle with a line through it, we use that as the angle. And that is our orientation angle. You want to stand Sokotoa at theta. One other thing you want to remember, or I say it, I make this a little fireplace. We don't ever want to stand Sokotoa in the fire. He'll catch on fire and burn. It's mean to do, right? So when we study trigonometry, it's about relationships. And that there are three really important relationships. Those are called the trig identities that we're going to talk about. We know them, sine, cosine, and tangent. But it turns out that there are three secondary ones. They're their weird cousins. And we're going to learn about those today too. And if you're in Algebra 2 trig, you've seen them before. So here we go. The three big ones are right here. It is sine, cosine, and tangent. And when we have Sokotoa, right, here he is. If you want to draw a little picture on your desk right here, we have three ways of looking at the sides of a triangle, of a right triangle. The first one is the longest side. And the longest side is always across from the fireplace. That is our hypotenuse. Our opposite side, right, is always across from the angle or Sokotoa. It's opposite him. That is opposite. And the side that's touching him, but is not the hypotenuse, that is our adjacent. Right? That's our adjacent side. Those are our three things that we're going to talk about. All triangles have three parts, a hypotenuse, adjacent, and an opposite, but they move around depending on where the hell little Sokotoa is standing. So the three most important ones, the three most important ratios Three most important identities that we're going to talk about: sine, cosine, tangent. And you guys know where these come from. It is SOHCAHTOA. Do I write that down every test I ever take in math? Yes, I did. Because why not? Right? Why not have it there so I don't have to memorize that sine is opposite over hypotenuse. And that cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Now it turns out that little baby SOHCAHTOA has a weird cousin named Shakato. What? You will never need to know his name because it's weird, but I'm going to tell you that his name is Ayo. Now, I'll be honest. I just had a kid tell me that once. He's like, oh, it's his brother, Shakato. And I'm like, you're such a weirdo that you made that up. But I'm going to show it to you. Here's what. Not only do we have the regular ones, we have their cousins that are the flipped versions. These are the regular, these are the flipped versions. In other words, these are the inverses, right? Now, here's what's tricky. It's really tricky because we got these three new words: secant, cosecant, and cotangent. And it's like, oh my God, how do I know which one goes with which one? And here's what. Cosecant is going to be friends with sine, and I'm going to give you a way to remember that in a minute. So if sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. It's just flipped. And you're not, and look at that. Oh, right? But I'm going to give you a way to remember. So just bear with me for a second, because once I tell you how to remember it, you'll be like, you'll never forget it. Cosine's weird cousin is secant, and it is hypotenuse over adjacent. And tangent's weird cousin is, instead of opposite over adjacent, it's adjacent over opposite. Now, I'm going to be honest. I don't memorize those. I only memorize these first three. That's all I care about. Here's what I need to know. All I need to know is which one partners, and then I flip it. And here's what I need you to write down. You ready? Every weird partnership has a co in it somewhere. I'm actually going to write that down for you. Every weird partnership has a co in it somewhere. Now I'm going to show you what I mean by that. Look at this. This guy is sine. There is no co in front of it. It's just sine. So his weird partner has to be the guy that has the co in it. Does that make sense? The cosine has the co, so his weird partner cannot have a co. And on this last one, tangent, no co, cotangent, yes. So that's how I remember it. I remember it to myself. I think, oh wait, cosecant, who does he go with? Well, since I already have the word co in it, he has to match with sine, because sine doesn't have a co. Does that make sense? Every weird partnership, one of them has a co. I can't have cosecant and cosine together. Too many codes. Does that make sense? Yeah. It's just the way they name them. They just put like each one has like a part. So here's what sine and cosine we're going to get are related. So it's like sine, and then here's his relation. Also, here's his relation. So he's got like the co is the relative. And since this one already is a co, his relative has to not have a co in it. Co just says that it's a co-relationship. So if you have a relationship, one has a co, one does not. So if I'm talking about who's cosine's weird cousin, it's got to be the guy without the co. Yeah? Okay. Another way to think about these guys is they are related, both the flip version and another way. Here's another way to write it. We do this more in January. Cosecant is the weird cousin to sine, right? Because he's got the co in front of it. So we can write it like this. 1 over sine. Secant does not have a co in it. So his weird dude, his weird relationship will be with cosine. And cotangent already has the co, so his weird relationship is with tangent. You can either flip them with opposite, adjacent, and hypotenuse, or you can flip them with their cousins. It works either way. But we worry about this more second semester. Let me show it to you now. And you're like, okay, Miss G, what does this have to do with anything? We're going to do a homework assignment tonight that we did in Algebra 2 last year. We're just adding in the new words. And it's really easy, right? So here we go. This is light work. You're going to like this. So the first thing is we need to orient our eye. Please, if you would, draw baby Sokotoa on this drawing. He goes where the theta is, right? So start by drawing him in. Some of you are going to say after this, I never want to do that again because that's a baby step. And I'm going to be like, well, then you'll miss the best part of geometry. So from that, please label your parts opposite, adjacent, and hypotenuse. Right now, label away. Opposite of baby Sokotoa. Adjacent to baby Sokotoa. I don't know why he's a baby. Hypotenuse is across the fire pit. So watch how easy this is. I'm going to do the first one, and then the second, and you're going to do the rest on this one. Are you ready? The sine, from his point of view, from theta, the sine of theta is opposite over hypotenuse. Now, I don't want to look up cosecant every time, because that's a pain in the ass. So I just remember, hey, it's sine's weird cousin. So what do I do to get him? I just flip it. I just flip it. Done. Let me finish the rest of the chart on this one real quick. I'll do it while you do it. Honest to God, I don't have secant, cosecant, and all that memorized. I just know who their partner is. That's all I do. I know Sokotoa, and then I just know so goes with co goes with sec, tan goes with cotan. And opposite over adjacent, or adjacent over opposite. Hey, can you wiggle your fingers if you got it all right? You're a genius. Right on, right on. Okay. We're going to bounce back to problem number 2 in a second. We're going to go to problem number 3. If you would do me a favor, I'd like you to look at problem number 3, and I'd like you to assign the oldest person in your table group to grab the calculator that's on your table. Everyone should have at least one calculator. If you want to use more than one, that's cool. We're going to do the same thing. We're going to do the same exact problem. We're going to have baby Sokotoa. We're going to figure out our stuff, but there's a problem. And the problem is this. We are missing a side. We're missing a side. So guess what? I don't know. Pythagorean theorem. You got to do a squared plus b squared equals c squared. Do I care which one is a and b? I don't. I do care which one is c. That's the hypotenuse. It will turn out to be a nice number. You'll do it on your calculator. It's really super easy. We'll do it together. I'm going to remind you, you're going to say 20 squared plus b squared equals 29 squared. And you know what? You're going to just use your calculator. Sarah, what'd you get, baby? You get 21? Oh, Sienna, how about you? It's because I missed it for so long. What is 29 squared? 21. Hey, 21 goes here. So guess what? Draw opposite, adjacent. Look, it's already adjacent. And hypotenuse, fill in your chart for me. Super easy. Yeah, perfect. So 841 to take away 400 is 441. So yep, it's a minus 3. He did that in the a little savant. I wish. So here come my answers. I got like 21 over 29, 29 over 21, 20 over 29, 29 over 20, and the last one, opposite, I always have to think that one, over adjacent, 29, 1 over 20, or 20 over 21. Okay, we're doing number 4 next, but I don't think there's quite enough room. So could you do me a favor and turn your paper over? We're going to do number 4. Number 4 is literally the exact same problem that we just did. The problem is they forgot to give you a triangle. So you need to draw the damn triangle. So flip your paper over and let's draw the stupid triangle, right? So here it is. There's my triangle. Make it a right triangle. There you go. However you want to do it. Put baby Sokotoa where you want him to be. It's up to you. I am going to put him right here. That's theta for me, right? There he is. You decide. Again, what that does is orient your eye. Now, label your parts. Which is opposite? Which is adjacent? Which is hypotenuse? I think this is opposite. This is adjacent. This is hypotenuse. Now, they gave us a little hint. They told us that cosecant is 37 over 12. But I told you Mrs. Tarantino hates those ones, so I'm going to flip him over to the sine guy. Are you with me on that? Are you agreeing that that is 12 over 37? Is everybody cool with that? Yeah? Well, now I know what the opposite side is. What is it? It's 12. It's 12. So I'm going to put that as 12. I know what the hypotenuse is. It's 37. If you were a brainiac and got it from that guy, yay for you. So do me a favor. Maybe make the youngest person at the table group do a little Pythagorean theorem. Figure out. It's a nice number. It's not a scary number. Just a little punch it in your calculator. Nothing hard. Oh, look at you stealing that. Don't do it. I don't know. I mean, I know what the answer is, but I don't know yeah, the hypotenuse is always C. That's the only. The hypotenuse is the only one we care about. It's always C. It's across from the bottom. I think we're going to say 12 squared plus, I don't know, squared equals 37 squared. Did you guys get 35? And then take that away from 37. So nice. Look at we're gonna rock and roll through this now. Super fast. 35 over 37. 37 over 35. So we're not freaking out that we had to draw it. Big deal. I don't care. 12 over 35 or 35 over 12. Now, we're going to bounce back to something. And I'm not going to lie. If you have Mr. Lyons, Greg, I think even if you have Mr. Cerise in geometry, you've already done what we did. I knew that last year I had a number of kids in Algebra 2 who cheated in Algebra 1 and did it online, and there was no way they were going to be able to do this next thing, so I didn't recover it, but, welcome to pre-calc. It's kind of why you might hate geometry a little bit, but we're going to be okay now because you're older and you're smarter, and you're going to be like, that's not so bad. So we're going to bounce back to this problem right here. Now, here's the good news. Everything's already there. So do me a favor, throw Sokotoa on there, label your parts, and then we're going to rock and roll with this problem. There is a little bit of stickiness, and we're going to talk our way through it. I'm going to relax you. I'm going to show you it's not scary, but you're going to think for a hot minute. Some of you are going to have a little PTSD, little bit of trauma. I'm going to get you through it. So here we go. Little Socotello. Oh, look, Socotello's red right now. I don't know why. There he is. Oh, sorry about that. And we got opposite, we got hypotenuse, we got adjacent. Okay. Now you're thinking, Miss T, I don't know why you're freaking out. All the numbers there. Nope. Pythagorean theorem. This is an easy problem. Why are you being such a baby? And here's why. Here is why. A sine is opposite over hypotenuse. Now, so far that looks okay. I'm going to do a little bit of reducing, right? A little bit of reducing. So I get 1 on the top. That's cool. And 4 on the bottom. Remember, outside guys reduce with outside guys, inside guys with inside guys. And here's the problem. The problem is, theoretically, we are not allowed to have a square root in the denominator. And here's why. Square roots go on forever. You can't literally divide by a number that goes on forever. You know, there's 2 schools of thought in mathematics. Some teachers are saying now that we have calculators, we don't need to worry about that. But there are a lot of old school teachers out there who are like, no, we need to fix that situation. It's called rationalizing the denominator. Again, Craig did it. I think Mr. Teresa did it. I didn't do it as much. Now I'm prepping some of my seniors to take college level algebra next year and kill it. You may have a professor who's going to say, no, you can't have that in the denominator. So we're going to talk about what to do when you have a root in the denominator. It is very easy to get rid of, but we're going to talk about what you need to do to do it. Are you guys ready? Here's what. The way to free someone from square root jail is to have a twin. Remember we talked about that. You and your twin, you both try to escape. One of you dies, one of you is free, right? So what we need to say is to this guy is like, you need a twin. We need to go sneak in your twin brother into jail. So we're going to do that. We're going to say, hey, here's your twin. But I'm not allowed to just randomly throw stuff on math problems. So here's the rule. What I do to the bottom is okay as long as I do it to the top also. Have I lost anybody? So watch what's really nice about this. Here's what I get on the top. 1 root 5, or just root 5. I'm cool with that. And here's what I get on the bottom. This is really cool. They don't cancel out. One gets free, the other one dies. So we just get 5. Super easy. It frees it from jail. Because really it's square root of 25, and the square root of 25 is 5, right? So this guy is really root 5 over 5. Is that cool? Now here's what. I don't want to flip this guy to get cosecant. I'm just going to flip this guy. Look how easy it is to flip him. Just root 5 on the top and 1 on the bottom. So you can flip him this way, but then you have to do that whole square root thing again, and it's a pain in the ass, or flip him in the very beginning, and that's cool as well.
Wait, so
yes,
for sine, then we have to like we show the math for sine without it.
We don't have to do it because we just flipped it, and then there's none on the bottom. Awesome. Okay, here's what I want to do. I want you to do cosecant only. I'm sorry, cosine only by yourselves or with your table group. Okay, so let's do it. Nice. We're going to do it together, actually. So here we go. We're going to say adjacent 8 over 4 root 5. Now, Jace, this is when I would flip it on the other side right away. Right? Flip this guy over. 4 root 5 over 8. Could I reduce that guy? Is there outside guys on that guy that will reduce? The 4 and the 8, yeah. So I'm going to get root 5 over 2. Okay, so he's done. He's done. Only one of them will be bad, right? Only either one will be bad and the other one's good, or one's good and the other one's bad. So here's what I want you to do. I want you with your table mates to fix that guy. Fix that. Here we go. Let's do it over here. 8 over 4 root 5. Here's my advice. Start by reducing the 8 and the 4. That'll make your math a little easier. And again, this is, most of you have seen it. You just hated it, but now you're going to be fine. Okay, get that root 5 up there, right? Once you get the hang of it, it's not bad. It's really pretty easy. It's like, oh, he gets a root 5, he gets a root 5, 2 root 5. Just remember, it's over 5. So we're going to practice a few of these because, again, my goal is to have you come back as seniors next year and tell me, I took college algebra and I killed it. What's this guy right there? Here's what's nice. Guess what? On the last ones, we don't have any. It's super easy. Just 4 over 8. Just 1/2. And 8 over 4. Just 2 over 1. Okay. This is a little weird. Here's your homework. I'm cutting some off. You ready? So here we go. You got time to work on this together? My advice, maybe do some of the back ones. Maybe do some of the scary ones. You remember seeing this video? No, Michael. I love Oh, thank you. Elena, will you go touch that brown button, the red stop button? I want you to talk to me. I'll get you. I'll get you.